Hey, hello. What's up, buddy?
Hey Fredrik, how's it going?
Oh, good to see you here. Justin Hill in my house.
Going, guys?
Hey Justin, not too bad. How about yourself?
I'm doing well. Just another exciting day. Should have a pretty good event coming up here. Let's dive into the consensus. I'm excited to hear from Dariia and Dr. Chen.
Oh, yeah.
Yeah, absolutely.
Audience pumping up.
Sorry Fredrik, you sound a little bit distant to me. I don't know if it's the same for you, Justin.
Oh, Justin, does it
Yes.
sound different to you?
Yeah, it's a little quiet.
All right, let me try to improve it. How about now, fella?
It's slightly better.
Yeah. Well, I'm using my earphone now. Justin, do I sound okay in there?
Sounding about the same to me.
Okay, another try.
There we go. That's much better.
Yeah, much better, yeah.
My iPhone was actually capturing my sound and reverb it. let's perhaps give a couple of minutes for folks to join in before we get started. Dr.
Hello.
Chen.
Yeah, I'm Ying.
Welcome
Yes,
aboard.
thank-
Time. Excuse me, Justin said something?
Yeah, good to go.
Sure, it's time. Really hard for me to moderate and temper my enthusiasm with today's event for a number of reasons. But first and foremost, before the introductions, please allow me to express our appreciation and our thankful recognition to all ambassadors and community members who relentlessly and generously provided feedback on technical issues, among other several number of technical considerations, both here on Discord and on forum throughout the previous phases, in particular the most recent non-incentivized Gemini 3 phase, of course. Believe me, your inputs proved crucial and extremely valuable for the project to reach the current state of the network. Our gratitude as well, shout out to the non-technical ambassadors and community members who also committed time and effort in content production, which, needless to say, plays a very important role in community engagement and stickiness. I can't thank enough the Subspace community for your loyalty and for believing in us. Thank you so much. Now, here on stage, the significance of this event is bringing all the new faces, or not so old. Chief among here, the usual suspects, Justin Hill. Thank you, bud, for joining. All good on your end?
It's a pleasure to be here. Thank you, everybody, for having. Like Frederic said, I just wanted to thank the community for all their hard work and, blood, sweat, and tears testing out, in progress software. I know it can be frustrating, but like Frederic mentioned, we would not be able to make progress without your help and valuable feedback. So thank you, and definitely look forward to continuing to get that feedback and hearing from our R&D team. Thanks, everybody.
Yeah, great. We're also very happy to count today on Emil, a notable rep of our community and lead ambassador. Thank you, Emil, for joining and for accepting our invitation to co-host, my friend.
Thank you, Frederic, for inviting me. Yeah, I'm really excited and thrilled to be here, especially helping out with the moderation, and we have an exciting agenda for today, so looking forward to it.
Sure. Frederica here speaking, yours truly, but excuse my favoritism, but the bright stars today to shed a light on the great developments of the new V2 consensus, Dariia, our research engineer, and Dr. Chen Fang, senior research partner at the University of British Columbia. Thank you so much for joining us.
Yeah, thanks. Hey, thanks for having me. It's so nice to see so many people listening in. I'm getting a little anxiety, but I will try to not to bore you today with all the technical stuff, but I'll also try to do my best to explain it. So we'll see. Thank you everyone for listening in.
Yeah, and thanks everyone, and in particular, right, for the invitation. And you know what? And this is my first Discord event, so I'm very excited to be here and to share, right, some of my understanding and insights with everyone.
Amazing. Yeah, we're super stoked to have you. Indeed, today's 3D release marks a very elevating moment in the history of Subspace, as it implements the new V2 consensus codename Dilithium to a great extent, especially in the archival phase, as they will show us. But not just that, across all three phases of the proof of archival consensus, that is archiving, plotting, and farming, and the algorithm in general, deleting offers many very interesting improvements to enhance its security and significantly improve our user experience. Dariia, Mr. Chen, again, thank you so much for showing up, and please keep me honest. The floor is yours.
Okay, I think to begin with, I will take a few minutes to give you all an overview what is Subspace consensus and how it is new now compared to what it was. And after that, Chen will give us an overview about its actual formal security and how it's revolutionary, what things about it are revolutionary in the field of, well, blockchains and consensus research. So the Dilithium consensus, the new version of Subspace and the old version, they're both a proof of archival storage. So we're still staying true to those of us who may have read our white paper. We're staying true to all the purposes and all the goals that we wanted to achieve. The fair, permissionless consensus, that is the Nakamoto consensus, so longest chain, that is proof of storage, the storage that is some useful storage, not some random data like in, I don't know, Space Mesh or some other protocols. But we have implemented it now, well, way better than it was. So we will have to update the white paper as well, but the purposes and the goals are stayed the same. So in our proof of archival storage, we want our farmers to store as many different pieces of our blockchain history as possible. And the more pieces one farmer stores, the more is their chance to win the block. So you could kind of consider it as proof of stake of your disk space, if you would like to reason in those terms. It's kind of way in between of like proof of replication and just proof of storage, because we do want to prove that you have pledged some certain amount of disk storage, but also that you're replicating exactly the chain. And this poses a lot of interesting questions about how do we prove both of them, and we hope to have resolved them in Dilithium, but Chen will fill us in on that later. But I will just describe it, how we're approaching this now. So the Subspace consensus is a protocol of 3 phases. It's archiving, plotting, and, well, the consensus phase, I usually call it farming, and you will all know it as farming. In archiving phase, given new blocks on the chain, the transactions, everything that's been put on chain is being constructed into some canonical history. It's been made sliced in the pieces of the same size. Each piece gets a commitment. Everything gets nice and uniform. We store the object mappings, what's inside every one of those transactions and things and so on, and give nice and clean and all uniform pieces for farmers to store. Next phase is plotting, that takes that history of the blockchain that's been sliced in those nice uniform pieces and lets each farmer create their uniform replica, their unique replica, based on how much space they have actually pledged to the network. So if you have 10 gigabytes, we're gonna write 10 gigabyte of pieces. If you have a terabyte, we're gonna give you a terabyte of pieces to write down. In the farming phase, after the farmers have plotted once, they can just go there and audit at every challenge and hope they will find a solution. And the more space they have pledged, the more are the chance of them to win a solution. The improvements that we have achieved from the first version to the current consensus are, I know, they're amazing. I've been with Subspace for a year, so I've been there when we're still finishing up to implement the first version of consensus and throughout the whole research of the new version. And it did undergo significant improvements. The first consensus was working, but it was not as good as we wanted to be. And we have diligently spent months and months and people hours of research to make it as good as we could in terms of security and user experience. So this now is going to be a lot of technical terms if that was not enough yet. But if you would like to know about this with more calm, more time to digest it, you should go read our Hitchhiker's Guide. There have been 3 episodes so far. They are delving in a lot of math, a lot of reasoning, a lot of what we have learned from the industry, from the literature to put inside this new consensus. So I strongly recommend that. We have put a lot of work into writing those and publishing them. They are on our Medium, and I will believe our hosts can put you the links to that. So, to the best and the sweetest, the improvements. One big improvement is the commitment scheme. We used to have the old and respectable Merkle trees, but they are now a little bit outdated. Well, they're kind of outdated. They have been here since like the 80s. Now we're using KZG commitments, which have constant size of commitments and of proofs to prove that the data you're actually storing is a part of history. And they do not depend on the size of data, while Merkle trees are. So this, again, is one of their best reasons why they have been so used and they have become so famous. Ethereum is going to be using KZG commitments. Polygon is going to be using KZG commitments, and like a lot of them are. Well, we're not staying behind. We're also going to be using them, but in our own way. So they provide short proofs, and they also provide a way to verify that the erasure coding over data was done correct. Why do we need erasure coding? To ensure that we never, under any circumstances, or network partition, or some farmers being not available, or some pieces being taken way too long to be discovered, or somebody with a lot of storage just leaving the network, that we're in under any circumstances are going to lose any data. So we're increasing the amount of data in history by erasure coding, which is also famous and battle-tested way to preserve data and ensure it's recoverable. And KZG, which is a more newer algorithm, it's like from 2010s and have been a lot of research in the last 10 years, well, almost 13 years now. It actually gives you a way to prove that erasure coding was done correctly, which is something that was not possible with Merkle trees, and we're happy to have it. And it allows us to avoid something you may have heard from other blockchains called a fraud proof, where you basically trust the the nodes to perform erasure coding correctly, but then if you discover something that was not correct or is not available, you ring an alarm, fraud, and you provide a proof. That's a pretty complex algorithm, and there have been a lot of problems with it in the industry, and I don't think anyone has actually implemented it to the fullest, and so we are avoiding it altogether with KZG. Which is amazing. A lot of min mass, a lot of polynomials and operations on elliptic curves and finite fields and everything I loved about cryptography from my university years, but actually applied to practice. I'm just so happy we've been working on this. Another significant improvement is that the plots are now much harder to compress. That was not so much the case with Consensus V1 by the way that it was plotted and the audits were done, but now we have overcome the challenge. So that's a great improvement to security, an improvement to user friendliness and the actual ecological impact of our protocol is the way that we have designed audits. They are designed more with SSDs in mind than with HDDs, because those are also a little more ecological. But we'll be talking about that maybe in other calls. What are the difference, why we have preferred actually more SSDs. But the way to design the audit is by favoring random reads instead of like large reads of your whole plot of your whole sector. For every like terabyte of storage, for instance, you have pledged, we're going to read just 32 kilobytes of each gigabyte, which is like a minuscule amount, just to see if you have won a solution. And only if you have won a solution, you would have to put more work. So it's actually like lightweight, and the prototype version that Nazar has implemented is like lightning fast. It's like not even optimized to its fullest, and it's already fast. And we have actually reached out to one of the largest producers of SSD, to their research team, to validate our algorithm with them, our assumptions about SSDs, and they couldn't find any like attacks or obvious ways to improve it, or so it was nice that we were able to validate it with actual SSD developers, that it's actually a valid optimized protocol for the audits. The plotting has been improved from being computationally bound against attackers to be memory bound, which is also contributing to its eco-friendliness, because you're going to be wasting less CPU cycles and more RAM, which is using less energy. And last but not least, we have decreased greatly network load, because the pieces into which we are now packaging history are now much larger, which is also due to what KZG allows us to have, small proofs, because with Merkle, it have been way too much space wasted to proofs. With KZG, it's not a problem. So now our pieces have increased from 4 kilobytes to like a little bit over 1 megabyte. So now you're going to have way less network requests to extract the data, less computation to require to prove it, and less computation to require to recover it. There have been a lot of improvements throughout the protocol. They're not related to consensus, which we'll probably be talking about in some other meetings. There have been a lot of enhancements to the networking, the DSN, the caching layer, the speed with which pieces are served. There's a lot. There's just way too much to cover. I feel like I'm already taking way too much time on it. If I am, somebody please stop me.
You're good. Go ahead, Dariia.
No, you got plenty of time, Dariia.
Okay, it's just like I can talk about this like for hours. So if you guys want to stick around, please do. If you actually want to hear me to talk about this for like an hour in like complete technical detail, there's a video on YouTube that I've did for our engineering team. So that's also recommended if you're like really interested. I want to highlight the improvements that we have done for plotting. Archiving has also been redone completely, but it's kind of easier, and I would probably say you go read it in our blogs. But plotting has undergone a complete redesign. And one thing that's important to highlight here is that we are going to be using a custom implementation of Chia proof of space, but in a way completely different as Chia does. So why we're doing that? Because like in the papers that predate Chia, they suggest this construction for a function that is easier to compute in one direction, but it's harder to compute in the opposite direction. And it's also easy to verify that it was computed correctly. And it's also, you can tune the amount of RAM you're going to be using to compute it and the amount of computation you're going to be using to compute it. And they actually suggest that this can be used as a memory bound function. So we basically work on that, but the only existing implementation of that so far is Chia itself. So we have adopted it so far, but we will, in the end, we will have our own implementation of it. So just saying. So what we're doing, we're taking a Chia plotter, but instead of plotting the way the Chia does, Chia plots like 100 gigabytes right away. What we do, instead of plotting this one huge Chia table and just storing it on disk, and that's like random data, and we cannot store that because we want to store useful blockchain data. What we do is that for every piece that farmer has to store, every piece of blockchain history, every piece of useful data, we generate a little Chia table, and we encode the piece with that random table. So what this allows us to have, and this like one simple trick, it allows us to have for every farmer, even if they may be storing all the same pieces of history, to have a unique replica because their encoding table will be different, and to actually verify that the farmers have spent the specific amount of memory that we require them to, and the requirement will be the same for everyone, to actually plot it. And this saves us from one of the common attacks on proofs of storage, which is on-demand plotting, which is basically somebody who has a lot of computation but doesn't want to actually pledge disk space. They fake their disk space with CPU cycles. They just maybe store like 50 gigabytes of history and try to fake that they have like a terabyte. So by using this trick with memory bandwidths and writing on with Chia tables, we can actually overcome that. It's amazing. So we're basically using Chia table as a black box. What you can imagine it's doing is like a set of outputs of a function where you have like an index and value, index value, index value, index value, and you can query it in like any index, and it will going to give you a short proof of space. And an amazing thing that we have not yet found in like any other, for example, there are memory hard hash functions or sloths that we used in the previous consensus, or basically any other function, which Chia table allows us to do is that if table is huge, the proof of that you have computed this is much, much smaller. So if we're talking table of like 2 megabytes, 4 megabytes, the proof that you have computed this table is like 128 bytes, so much, much shorter. And it's also much easier to verify for the verifier instead of computing it. This is something really unique in the world of memory hard functions and also computational hard functions. And that's why we have been so attracted by it. Again, if you want a lot of detail, go read the blogs. There's a lot of caveats to that. We had to rewrite the algorithm basically because Chia writes it again directly to disk and stores the plot. We don't want to do that. We want to store our own data. So that part of consensus is still in the workings. It's not yet available on Gemini 3D. The part that is available on Gemini 3D already is updated. And the one that we actually want to test as well with the Gemini 3D is archiving. And archiving, basically what it does, it takes the chain blocks that are confirmed. Right now, our confirmation depth is like 100 blocks to ensure that there are not going to be any more forks in the organizations, and that we know that we can save this data to the permanent farmer storage, and we'll not have to rewrite it. So once some certain amount of blocks is confirmed, which is deep enough from the tip of the chain, they are added to a buffer, the archival buffer. It's sliced into those uniform pieces of 1 megabyte each. For each megabyte, we compute a short KZG commitment with which you will be able to prove that it does belong to actual chain history. and that any smaller chunk of that 1 megabyte also does belong to this piece and does belong to history. So this is why we're able to do audits that are much, much smaller than the whole sector and the whole plot, because we can actually prove that even those tiny pieces, those tiny chunks, are actually a part of history without having to scan or audit the whole thing. And that's what makes it so much lightweight. After we have computed KZG commitments to all those records, we erasure code them, as I have already mentioned. And KZG allows us to guarantee consistency of that erasure coding, and without having to trust anyone and without relaying to full nodes to having to redo it themselves. And one of the features that is not yet on our new consensus, but is a step for achieving the no compromises scalability of Subspace, is that this way the archiving is designed will allow us to upgrade into distributed archiving and to sharding without having to rely on full nodes and without having to basically compromise scalability with everybody redoing the work all the time. And yeah, again, if you want to know more about this in detail, I know I'm just going lightning fast about all of it, and it's pretty dense. Go read the blogs. If you have any questions in the blogs, there are also links to even more technical specification of that. And there is a link to our research forum, which we're always available to answer in-depth questions about theory and practice. And if you have had experience with other blockchains or networks or research in this field, we'll also be happy to hear about that. I am in the second blog, I'm also providing the comparison of our archiving construction to like the one proposed by Polygon and the other one proposed by Ethereum. So if you're interested in that, you could also go read that. And in the third episode, I described the lithium in like its all glory. Yeah. I think I am going to wrap up for now and give this scene to Chen, that's going to explain why all of that is actually secure and how it's better than everyone else.
Yeah, thanks a lot, Dariia. Great job. Now, right, my job is much easier, right? I will just explain one thing, right? What is revolutionary for our new consensus based on what Dariia just shared with us. So, three things, three take-home messages, right? Number one, we are the most efficient proof of storage based on useful data, right? So let me explain a little bit. Previously, there were several proof of storage protocols on useful data, and they are very slow. And because of a fundamental reason, right? Most of them are based on a technique called graph pipeline, and that technique leads to complicated construction, so that it's slow to construct the graph. It's the proof size is large and it's less efficient to verify the construction. So that's why and we are from day one we were asking ourselves the fundamental question: why this storage, a proof of storage on useful data has to be slow, can't be as fast as a chair. So inspired by this question, we kind of figured out a new way and to use chair tables, completely different from what like a chair is using, so that and we can support useful data. So to sum up, we take the best of both worlds, we kind of borrowed the efficiency from chair and we improved the efficiency even further and then apply it to useful data so that we can outperform, right? Like the protocols on useful data. Second point is about the storage cost, because we know, right? Like the blockchain in the future, and they will be the backend for Web3, right? Even for metaverse. So that's why we need to bring down the online storage cost significantly, maybe orders of magnitudes. 10 to the power 6, right? 10 to the power 7. This is the kind of improvement right we want to achieve. So luckily, I feel that Subspace new consensus is in a very good and unique position to achieve this. But one reason, unlike proof of work and proof of stake, right? And we are like a proof of useful storage. That's why we can create a data marketplace, right, to like bring down the cost. And we will have some details later. Last thing is about security. From day one, we put security right, in our consideration for our new consensus. And so that's why I already put something in our research paper, and due to the time limit, the conclusion is, and that's why our like security, I believe, and currently is among the best of like this proof of storage, because even from day one, we considered this, and we borrowed many excellent ideas from proof of work, proof of stake, and to enhance the security of our proof of storage. So to sum up, three things. Number one, efficiency. We managed to take the best of both worlds. Second is about online storage. This is our unique strength. Last one is about security, like built-in security from day one, like learned many things from like other designs so that and we can be among the best. And that's all of a quick summary. And for details, Dariia has so many good resources, and also I would encourage you to read our research paper. It's like updated over time. And thanks everyone. That's all from my side.
Thank you so much, Dariia and Chen, for your comprehensive explanation covering so many topics and involving so many innovative factors. Allow me to be repetitive. It is also very helpful to review all these new insights on our YouTube presentation, which we share on the chat. It will give us also an illustrative rendition of the new engines and the new and the new upgrades. And for a more comprehensive literature, we strongly encourage you to access our forum and check our Hitchhiker guides episodes 1, 2, and 3. But that said, I'll open the floor for questions, and we're more than happy to debate the insights brought in here today.
Yeah, and you can throw your questions into the chat. So you should have a chat on the right side of you on this event page. If you don't, in the top right corner, you should see a little chat text button. Additionally, you can also raise your hand, and we'll bring you up to the stage here for questions.
Yeah, thank you very much, Dariia and Dr. Chen. We can really hear your excitement in the voice when you were talking about the consensus version v2, and I'm pretty sure the whole community is also excited to feel this enhanced user experience when trying out the new release for the Gemini 3D.
Well, I'm afraid that the first maybe implementations that we push for testing are not going to be exactly up to our highest standards of efficiently, but well, we're going to continue to optimize, but first we need to validate that it actually works on a great scale and that we can improve it and optimize it even further.
Dariia, there's a question from Big Jim. If memory bandwidth is used in the plotting algorithm, Does that mean faster RAM would give a farmer an edge?
I think maybe Chen can speak to that better, but I would assume, well, it should. But it's also that faster, that's more difficult to get than faster computation. So that's more secure in that way than like computation-bound functions like floss that we used to have in consensus V1. But I'll let Chen get this.
Yeah, thanks, Daria. So two things, right? One is from this plotting phase, or sometimes right we call it initiation, and in the literature. And in this case, right, if you have fast run, and you can be like faster, right, in terms of plotting. And then later on in the farming phase, in terms of security, it's right, and it's not the case, and kind of right, and because we put like the security right based on memory bandwidth, and like the efficiency of like the fast memory bandwidth is only helpful and for the setup phase.
Yeah, and there's a comment from Nazar complementing your response. It's about memory bandwidth. The difference between fastest and slowest memory is much smaller than the fastest and slowest CPU. Very interesting. Trending H. Kwong, will users be able to put data on the chain by spending Subspace coin? Not quite sure I understood the question.
Yeah, if I understand correctly, so the trending Kwong is asking whether like users will be able to upload their data to be stored on the Subspace. And at the moment, it doesn't seem like it would be one of the use cases for the Subspace, as it's mostly used for backing up the blockchain history. So in my opinion, at the moment and in the future, this won't be the use case for the Subspace. So we're not going to go with just the consumer market.
Great, thank you, and thank you, J.R. Washburn, for your insight on and for supplementing the response. Sure enough, could you provide a CLI utility to benchmark plotting performance that should help to evaluate hardware configurations and how they impact plotting performance?
Well, that's a request we should provide to our engineering team. If there are users that are interested in that, we should totally get that. But if you are really really determined to do so, there are benchmarks in the code. If you can compile it from source, you can do that. But we'll pass that request to the CLI developers.
Dariia, I'm also curious to ask, you mentioned that with the new consensus, it's becoming more SSD friendly. But for the other users who still have their own usual hard drives, will still they be able to participate in a Gemini 3D?
No. So Gemini 3D does not yet have the new audits. The way they were designed to be SSD friendly, it only has the new archiving that has not yet anything to do with that. And the thing is that like it's not like people with HDDs will not be able to participate at all. It's just that for them, auditing will be slower because SSD is much faster. But going in the SSD direction was also important for us from our, well, you can maybe say political standpoint, because we want to have the consensus as reachable and as open to everyone. And we have seen in the market that SSDs are growingly becoming a bigger share than HDDs. And we also want to open doors to people with commodity hardware. Like I am running Subspace not on my Mac laptop. like I didn't have huge HDDs, I didn't have any of that, but I'm still able to participate, and that's amazing. And again, it's not like HDDs is going to be completely excluded, but it's more friendly towards people with smaller space that bravely can just pledge whatever they have on their computer right now and be able to participate in consensus, which is kind of unique in the world of blockchains to have that low bar of entry.
That makes sense. Yeah, thank you, Dariia.
Another question we have from a big pump here is, does Gemini 3D have any planned rewards? Do you want to take that, Fajik?
Sure. I mean, not at this time. We're still running the non-incentivized phase, which will continue for some time in 3D, possibly 3E. But yeah, at the near future, I can't precise an exact date. We will resume the rewarding incentives and tokenomics. But I can't state a precise date as of yet.
And I just want to mention as well, as with 3C and just our overall Gemini 3 plan, with Gemini 3, we will be releasing various breaking changes as we move through. So for those of you that have been here a while, we started with 3C, and now we're into 3D. There will likely be a 3E, and so on and so forth. So, you know, there will be continuous changes, and at some point throughout there, we will enter an incentivized phase for Gemini 3. We don't know if it's going to be 3D or exactly when, but we will go into that phase and then hopefully quickly approach mainnet beta from there. Alrighty. It looks like we don't have any more questions. Did we have any more questions from anyone here up on stage with us?
No, not at the moment. I think it's very clear.
Alrighty, so from there, I think we'll go ahead and move into a quick tutorial on getting Gemini 3D installed and set up and everything. I will be going ahead and sharing my screen for that one. So give me just a moment to get set up here, and we'll go ahead and move forward.
An anecdotal question as Justin gets the tutorial prepared. The KZG schemes commitment, very interesting mathematical scheme, and a widely used polynomial are affectionately referred to as moon math. Can anyone explain exactly when the moon math the moon math term comes from? Perhaps because of its complexity.
I think we have called it moon mass more, not just about its complexity, but the way all of the things so elegantly play out together. Like KZG existed in its own space, and Richard coding is also based on polynomials. KZG is based on polynomials. So Richard coding has existed since, like, I don't know, the 50s, if you go back to like radio signals, maybe even earlier. And then we also have the elliptic curves, in which we have our private and public keys and signatures. But KZG also works on elliptic curves. And also KZG allows us to prove data that's actually bigger than the original polynomials that we use for data. And all of it just falls in together in sometimes even in unexpected ways. But like the only way to actually discover that these things do fall together in such a way that actually works and is efficient in practice has taken a lot of understanding and a lot of reading papers, a lot of discussions, and we have spent a huge amount of time. There are like thousands of pages read, hours and hours of discussions, and there's also Chen here. There's Jeremiah has put hundreds of hours into this. Nazar has participated in discussions trying to keep us in line with practical expectations of how is this all going to work. We have other research affiliates, and it's just as beautiful as the moon to see it all, the puzzle finally complete.
Very, very well. As beautiful as the moon. Thank you so much, Dariia. Sorry, Justin, I interrupted your the start of your presentation.
Yeah, no worries. We actually had one question come through as we were getting set up here from Zorano. He asked, have you worked with the Chia team reviewing what you guys are doing, or have you at least talking with anybody at a high level?
Yeah, we have actually did reach out to the people who have actually wrote that paper that suggests a similar usage of those tables that predated the Chia protocol. So we have talked with those people to validate it's actually a valid usage. And we're continuously, well, mostly Nazar are talking on them on GitHub, asking questions, why is this works like that? Why is that parameter here? Can we optimize this? Can we do this and this and that way? And so on and so forth. So we're also in touch with the developers.
Keeping homage to our good open source sources. You gotta keep everybody working together. So that's always good as well. Looks like we had another question pop up here from Anna V from some community members. Will the 3D network go into the rewarded phase afterwards without a reset, or will they reset, or will they be a reset / a new network? I can go ahead and take that one, Anna. It most likely there will probably be a reset at some point before we get to the incentivized phase. But as Fajik mentioned, a lot of that is still up in the air as our developers make progress through the various changes required to get this new consensus and all of its technical nuances implemented. And there's another part in that question. So now the sync speed is very, very low. Is this due to the fact that a lot of participants ran to synchronize the nodes, or is that just the network is not going well? Should we expect an increase in the speed of synchronization after most of the participants are synchronized to the current block? And how can I increase the speed of plot synchronization? And on that one, yeah, as Nazar mentioned in the chat here, it's primarily due to the fact that we're not fully optimized. As you mentioned, Anna, it is a peer-to-peer network as well, so there is a factor of how many nodes are on the network and synced and everything along those lines. And obviously, your geographic distance to those other nodes as well is also going to come into play. So, for example, if you're like the only person in Australia that's syncing and the closest node is someone in Japan, it's going to be quite a while for you to sync, but that's just the nature of peer-to-peer networks. As you mentioned, as the network grows, we get more peers. That will obviously bring that down, and we will obviously continue to also work on optimizations and improvements with this new consensus as we get it rolled out. Without further ado, though, let's go ahead and get started onto this tutorial here. Can everyone see my screen?
Yes, we can, yeah.
Awesome.
Yep.
Alrighty, so on my screen, we'll see I have two windows open. Obviously a browser at our documentation site, which is going to be docs.subspace.network. And then I also have a terminal open. In my case, I'm using Windows. If you are on Windows, it's important to use PowerShell and not command prompt. If you're on Mac or Linux, obviously just any traditional terminal will do the trick for you. In our case, we'll go ahead and click the Docs button and go to Getting Started with Farming. So obviously, anytime you're farming or mining or doing anything participating as a node operator on a blockchain, you do need a wallet to receive those tokens. So we do have a section here on how to get your wallet set up. We do recommend the Sub wallet. That is a wallet that is made by the amazing Sub wallet team. They're not associated with Subspace, but we do work closely with them so they can support the Subspace network. And they also do make an amazing, in my opinion, the best Polkadot-based wallet or Subspace-based wallet. So we won't dive into the full setup. It's pretty much similar setup to a MetaMask or any other wallet you may have used. But ultimately, we will just need our public address to receive those rewards on. As far as running our farmer, we do have two routes. We have the advanced CLI and the simple CLI. The advanced CLI is going to be the more traditional route. If you've been here for a long time, that's how we used to run it in the past. That's great for complex, complex custom server setups. But if you're just, trying to test it out or run on a simple laptop or something like that, in most cases, the simple CLI will probably be your best case. Before we move forward, one thing that's always worth mentioning with farming, or really any mining or anything along those lines, is very network intensive. So obviously make sure you have a stable networking connection, and especially make sure that you don't have any data cap or anything along those lines. You will probably quickly approach that data cap and then start facing some issues. So if you're on Starlink or LTE kind of internet, you may want to verify your usage plan before moving forward with farming. As far as the hardware minimum specifications go, we do require about a 4-core CPU, at least 4 gigabytes of RAM, though we recommend probably about 8. As Dariia mentioned earlier, the RAM is one of the hardware pieces that does factor into our plotting speed. Generally, we'll want about a 4 gigabyte of swap space. If you're on Windows or Mac, you generally don't have to worry about that. It's kind of automatically done in the background. I think so on Linux as well. But just something to keep in mind if you're messing with a complex, custom setup or something along those lines. And then storage, we will need about at least about 100 gigabytes of SSD-based storage. Like Dariia mentioned, you could try a hard drive, but it's not quite going to be as optimal, and SSDs will probably be best moving forward. Simple warning about CAL file systems. It's very unlikely any of you will be using CAL file systems, but keep that in mind in the case that you are. As far as required ports, so we do require some ports being forwarded to properly connect to the DSN and the network. In this case, it's going to be port 30333 and 30433. We do have a nice little guide here in our documentation on how to forward ports. If you need any assistance, and there's also plenty of resources on YouTube and throughout the internet that can also help you out with that, getting that forward. Into the main actual installation. So as far as getting the actual CLI going, it's pretty straightforward. As you can see in our documentation, we have various tabs for which operating system you are on. In my case, I am on Windows. And then we have 2 versions of our executable files. As you can see, we have a version 2 for older processors from 2009 and some older VMs, and then a version 3 for newer processors in 2015. Some older processors beyond 2009 may not be supported. You can definitely try it, see if it works. If you are having trouble, you can also build from source on that hardware, and you may have a little bit more luck as well. But generally, any relatively modern computer should be able to handle with no problem. We'll go ahead and get that CLI downloaded. Alrighty, in my case, I already have it here, but obviously we'll just click Save. Alrighty, so once that's done, we will move on to the next step here, and we will see that we have, our first step is to initialize our farmer. This can be done with the simple command of the file name, followed by init. So I'll move over to my terminal here. And first, I will change directory to my downloads. So obviously, with any terminal command, you need to make sure you are running it from the directory that contains the actual exe. So if I list my directory, you can see Subspace CLI Windows.exe is there. If you don't see that in the directory you're in, you probably won't be able to run the command. So then we'll just type / and the file name. And the first command we will start with is init for initialize. We'll see a nice little Subspace network ASCII art, and the first question will be asking us for our reward address. In my case, as I mentioned, I already have my wallet set up. One thing you'll want to do is when you default set up the Polkadot wallet, it generally starts with allow use on any chain. You'll notice when I selected that, my public wallet, my public address switched from an ST to starting with a 5. We want to make sure it starts with the ST, as that is the Subspace testnet-based wallet address. If you don't start it with the ST, you may not see the rewards into your wallet properly. So we'll go ahead and paste that in, hit enter. and then it'll ask us for the name of our node. So this is just the superficial name that you will see on the telemetry. It is public, so just make sure not to enter anything, personal or private that you wouldn't want the world to see. And then here we'll specify the path for our plot files. This is where you would punch in if you were using an external hard drive or a D drive or something else like that, that is where you could clarify this. In my case, I'll just be using the default. And then the same with the node files. If you wanted to store that on another drive or somewhere else, you could also move that as well. Once again, though, I'll be using the default. Then we can specify the chain spec. For 3D, we're going to want to keep that as the default. Though if you are a developer, as you can see, there is the dev and the devnet options to kind of play around with some things. And obviously, as we continue to add more networks, that was where we can set this option as well. Alrighty, and then we see ready for liftoff. Run the following command to begin. And it gives us file name and farm. So from here, we will just run a simple farm. Now, before I hit enter, one thing I'd like to mention is there is the option for the verbose flag here. So if I were to just hit farm, all we will see is a simple starting farming ... with very minimal output and updates as they come. Give you an example. It just says starting node, and then it'll kind of slowly progress. A little bit clearer as well. And then from here, we will see the node is starting up, and it's kind of off to the races. So obviously, we'll just want to make sure that it fully gets through its startup process successfully, no major errors or anything like that. But from here, you are good to just let your farmer run, and it is at this point considered, running. It'll start with the syncing phase, where it'll catch up to the highest block on the network, which may 200,000, for example. So that will take some time. Once you fully synced, then the plotting phase will begin. And once plotting is completed, you should be off to the races on fully farming and starting to see rewards into your address as you win them. Obviously, the amount of your plot does pertain to your percentage chance of winning a reward, so keep that in mind on calculating how long you should be waiting potentially before getting any rewards into your wallet. But from here, we're off to the races, and you can always, one thing I like to double check just to make sure my node is working, is going over to the telemetry server. And then we'll make sure we're on 3D. There we go. And then on this screen, you can just type to search for nodes. So I will just search for my node. Awesome. And we can see it's there, and it's already syncing. From there, that's everything. So if we have any questions, I will definitely be in the Discord server throughout today, answering support questions and trying to help everyone get up and running with Gemini 3D. And if you do have any trouble, please report back to us. Obviously, you're welcome to post your questions here in Discord. We also welcome on our forums as well, so we can get escalated up to our developers as we get that valuable feedback from you all. And hopefully we can get everything moving forward.
Thank you very much, Justin, for such a detailed guide.
Of course. I'll hand it back over to you guys.
Yeah, we do still have some time. If folks have any questions pertaining to the installation or any other issues they might be experiencing, we can either, like Justin said, we can post it on our chat here, or if you want to give it some time to iterate, you may reach out to us on Discord and forum. Your feedback extremely valuable, as we have highlighted. But if not, I wanna thank you again for everyone's participation. Our special guest, Emil, thank you so much for joining forces and help us out in this in this very important milestone. And
Thanks for having me.
Unless everyone has any further considerations, I'll happy to respond them.
Thank you for inviting me and Chen today. It's been a pleasure talking about the new consensus. And again, I could do this for hours. So if you want to have another event, I can always do it. So keep that in mind. Thank you everyone listening in. I apologize that there was way too much technical detail, but there is a lot of material we have shared if you want to dig really down into that. Thank you everyone for listening.
So much, everybody.